Thank you so much for giving me an opportunity to present my thesis in front of you guys. So my PhD is all about like predicting different soil contents such as soil organic carbon, nitrogen, or this stuff from the remote sensing data. So I have started my research doing the taking the hyperspectral data as a first choice. So we found that in this existing literature, they have shown like there is a very potential from the hyperspectral data that we could get information from the soil, carbon, and nitrogen and this stuff. So we have used in this paper we have used like a wide range of machine learning, deep learning algorithm, and some band selections algorithm to see how much we could get the accuracy to estimate the soil organic carbon. And our research shows that for the organic carbon, we have got 90% accuracy in terms of the R square value. And in the next paper, we have followed to like see the what could we get the in terms of the efficiency of soil organic carbon if farmers use their mobile phone to take the picture of their soil, and whether they can get a very rapid estimation of the soil organic carbon or not. And in this stage, we have got accuracy up to like 85% for the carbon. And so in this, so if from the still RGB images, we can be able to extract the soil organic carbon. In the follow-up paper, we moved to our research from the hyperspectral data to the satellite data, because the satellites covers a very vast area. So we predicting that. So for the whole Australia coverage or even for the whole world map coverage, whether we could be able to estimate the soil organic carbon or not. So from the hyperspectral data, previous studies already shows some potential, and for the satellite data, they have might be some potentials as well. So in this stage, we are proposing two novel indices, that is the DSI and DVI, that can be handled like the dry soil and dry vegetation on the top of the soil. And in this case, we have put through some threshold values in there, and like also took the NDVI like all the conventional studies does, and we filtered out the bare soil, and we have got R square for carbon is 52%. In our next study, this paper is also is under review. This study we have tried to build to see some using advanced deep learning model to see whether the carbon estimation can be improved or not. And in this case, we have proposed the hybrid Bayesian attention model, which is like the advanced deep learning model. And attention model works like it gives some features to give some certain attention. That means they are the most vital and they are not. And we have considered those band, and our model performed up to 67% accuracy in terms of the R square. In our next follow-up work, we have used transformer guided model. So what we have found that when we are dealing with the Landsat 8 satellite data, these satellites data are really highly prone with the noise, because from the satellites there are lots of clouds, lots of grasses, some are like the very noisy environment. So we think that the satellites data needs to be the noise free, isn't it? So that's why we have developed a model which is called the noise detection approach by using the transformer model. And we have also used the CGAN model, that is the conditional GAN model, to like make the data set noise free, and then we feed like some conventional machine learning models and this stuff, and we got up to accuracy of for R square is 73%. And then next work, our targeting the vegetation, because all the existing studies says that if there is a vegetation on the top of the soil, all the learning based model gets very confused, because due to the vegetation, the satellite reflection gets very biased, so machine learning model cannot be able to predict anything. So in this case, we have achieved 0 R square, that means it fails to predict anything, but we have proposed some correction correlation matrix that handle the vegetation. That's why we are able to eliminate the vegetation impact on the top of the soil, and from using attention model, we have achieved like from 50% of R square value, so still we can predict if there is a vegetation on the top of the soil. And in the next work, what we have trying to do here, the previous work we have used some correlation matrix, which is kind of like a matrix based, table based system. But in that follow up work, we have made the model whole like the automated system. We have designed a robust model which is called the reflect GAN, and that GAN model used to take like all the vegetation soil sample, or even the bare soil or the mixed vegetation, and it can handle the like the soil properties. So in this case, we have achieved 53 to 57 in terms of the R square. So I would like to conclude my presentation about giving you a very quick takeaway message from my presentation. So if you are using the hyperspectral band to achieve the soil organic carbon, you will get very good results, almost 90% accuracy. If you use your mobile captured image, it also gives you the performance up to 70 to 80%. And if you use for the broad sense of images like from the satellite, you can still predict if it's a bare soil, then you can maybe predict like 50 to 55 to 65%. And for if you use like the mixed vegetation landscape to predict the soil organic carbon, still you can get up to 50 to 60% accuracy. So my project focusing developing a imagery-based decision support system to estimate the soil organic carbon. So thank you so much. If you are really interested in my research, you can scan my Google Scholar profile for the full papers. Thank you so much.